Hello, so today we're going to be solving systems of inequalities. So very much like graphing lines and then doing some shading in. But first let's kind of review when we're going to have a solid line and we're going to have a dashed line. So looking at your 3-3 note sheets there, it says to look at the inequality sign to determine if the line will be solid or dashed. So be a solid line, you either have to have a less than or equal to, or you have to have a greater than or equal to symbol. If you have a less than symbol or a greater than symbol, you're going to end up having a dash or a dotted line. And then the second thing you want to note is after you graph your lines and you've had your solid lines and or your dashed lines in there, you're going to have to pick a point on the line and plug it into the inequality. If the ordered pair you choose makes inequality true, then you shade on that side of the line where the ordered pair is. If the ordered pair you choose makes inequality false, you want to shade on the opposite side of the line where the ordered pair is not. And for the most part, as long as the ordered pair 0, 0 is not on the line, I usually pick that one as my point that I'm going to use. So let's come over here and let's graph this system of inequalities here. So we've got y is greater than or equal to x. Notice it's an equal, so we're going to have a solid line here. And this other one, y is greater than or equal to negative x. We're also going to have a solid line because you've got that equals underneath it, that line underneath it. So they're both going to be solid lines. So looking at that first one there, and when I'm graphing this out, I'm graphing it out as if it's y equals x plus 0, and I put that 0 in there just to remind you that's my my y-intercept there. So that being my y-intercept, I'm going to go ahead and put a dot there. And then my slope here is my rise over my run. And here it's going to be 1, 1, 1, 1, 1, 1, 1, 1. I can go the same thing the other direction. Connect those points, and it's got to be a nice solid line there. And then I'm going to go ahead and shade while I'm at it. It says it has to be greater than or equal to. And remember, I'm going to pick a point on the line. Well, a point on that line is 0, 0, and so I can't pick that point. I got to pick something else. An ordered pair not on this line is like 3, 1. So I'm going to pick the ordered pair 3, 1. And that's sitting over here, 1, 2, 3, 1. It's on this side. So if I plug in 3, 1, 1's my y value, and x is my 3 there. So is 1 greater than or equal to 3? No, 1 is not greater than or equal to 3. So I'm going to shade on the side that's opposite of that. So shading on the side that's opposite from 3, 1 is on this side. So I'm going to go ahead and erase that point so I don't get it mixed up with something later. So looking at my other one there, this one here, y is greater than or equal to negative x. So again, with this one, my y-intercept here is 0. And then this time my slope is negative 1 over 1. So I'm going to come down 1, 1 to the right, 1 down, 1 to the right, so on and so forth. And it's got to be a solid line, we said, because of the equals underneath it. So then we got to figure out how to shade this. You got to pick a point not on that line. And a point not on that line, I can use that same nice point at 3, 1. You don't have to use the same point each time. Just pick a point that's on that line. So I like it when it's the same, if I possibly can get it. So is 1 greater than or equal to negative 3? Yes, 1 is greater than or equal to negative 3. So I can shade on the side where that point there is, and that shading on that point is on that side of the red line there. And so I can see where the overlap is. The overlap is right over in here. So that is my result. My result ends up being this portion of the green line, this portion of the red line, and then this shaded in part. So let's look at another one here. So again, kind of using that y equals mx plus b way to graph it out. So b being my y-intercept and m being my slope there. And I can see I'm getting two solids again because I'm looking at my symbols here, and you've got the equals underneath it. So they're going to both be solid lines again. So graphing that first one, the y-intercept there is 2. And then my slope there is negative 1/2. So I'm going to come down 1 and run 2, come down 1 and run 2, come down 1, run 2, connect my points, and I said this would be solid. Didn't do that very well. There we go. And then I'm going to shade in accordingly. Pick a point not on that line. This time I'm going to pick 0, 0 because it's not on that line. And again, it's up to you as long as it's not on the line. So 0 is that less than or equal to negative 1/2 times 0, 0 plus 2 is 2. So is 0 less than or equal to 2? Yes, 0 is less than or equal to 2. So I'm going to shade on the side of the line where 0, 0 is, and 0, 0 is on this side of the line. It held it true. So now I'm going to try my other one here. Again, I'm going to graph the y-intercept here first. Slope there is 2 over 1. So I'm going to rise 2, run 1, rise 2, run 1, rise 2, run 1. Connect my points. It's got to be solid, we said. So pick a point not on that line. I'm going to pick 0, 0 again. It's not on that line. 0, 0 is right over here. I'm going to plug it into my equation here. Is 0 less than or equal to 2 times 0, 0? Minus 3 is there is negative 3. Is 0 less than or equal to negative 3? No, it's not. So I'm going to shade on the opposite side where 0, 0 is. And on the opposite side here of, not on this side, I'm going to shade on this side because it's the opposite side of my green line there. And so the overlap just ends up being over in here. So any ordered pairs that is over there in that region is my solution there. And sometimes, however, it's not in that same form. Sometimes it's in that ax plus by equals c form there. So it's up to you. You can put it in y equals mx plus b form. You can use your x and y-intercepts. So you can use your cover-up method to find those. It's up to you. So this is dashed because I'm looking there at the sign there. Look at the sign here. I'm seeing that solid line. So that first one there, I could use the cover-up method. If I use the cover-up method there, it's x plus y equals 2. Covering up the x there, I get y equals 2. And if I do the other one, x plus y equals 2, I can cover up the y. So x is 2. So x is 2, y is 2. I'm going to connect them, and when I do that, I'm going to make it dashed. We could also do y equals mx plus b, so in other words, I would have subtracted x, and gotten y equals negative x plus 2, and then graphed exactly like we did on the last side there, the last page. So then I can decide how to shade this in. I'm going to pick a point not on the line, so maybe like 0, 0. Plug in 0, 0 in here. So 0 plus 0 here is 0. Is 0 greater than 2? No, 0 is not greater than 2, so I'm not going to shade on the side where the point is. I'm going to shade on the opposite side. So I'm going to erase that point there. Oops. And then let's look at the next one here. So our other one here is we got 3x minus y is greater than or equal to negative 2, and this one's going to be solid. We could use the cover-up method, and maybe we'll just do that. So minus y is greater than or equal to negative 2. If I cover up the y here, I end up getting 3x greater than or equal to negative 2. Divide by 3, so x, I should have said equals in here, equals negative 2/3. So now I can kind of approximate that where that would be. I'm going to use blue this time. So negative 2/3 about right there. And then if I use the cover-up method again, this time I'm going to cover up the x. So I get negative y equals negative 2. Divide by negative 1, and y there is 2. So I can simply connect those, and this time I said that was solid. So then you got to decide what way you're going to shade it in. I'm going to pick that point 0, 0. If I put 0, 0 in there, I get 0 minus 0, there is 0. Is 0 greater than or equal to negative 2? Yes, 0 is greater than or equal to negative 2, so I'm going to shade on the side where 0, 0 is. So it's on this side of the line. And then I can clearly see the overlap over in this region. So I know that's my solution. And again, you're going to also put it in y equals mx plus b. So if I were to do that, I would subtract 3x. So I got negative y is greater than or equal to negative 3x minus 2. Divide everything in here by negative 1. If I do that, am I going to switch my sign here and I get 3x plus 2. And I could have graphed it out like that as well. So it's up to you. If you prefer putting in y equals mx plus b, or if you prefer using the cover-up method and graphing those out. So we got some other ones to go through, but I'm going to stop it there for now and give you a little bit of practice on some of these, and then we'll continue the second part later. So